Welcome! Let's take a look at using the fundamental theorem of calculus to help us evaluate a definite integral. In this case, we have the integral from 1 to 8 of the cube root of x plus 1 dx. So recall, with the fundamental theorem of calculus, we'll need to find an antiderivative of the cube root of x plus 1 and then evaluate that antiderivative at the upper limit and subtract from that the value of the antiderivative at the lower limit. Now keep in mind, this only works if our integrand, our f of x, is continuous on the closed interval. Well, the interval we're looking at in this case is the interval from 1 to 8. And the function, the cube root of x plus 1, is continuous for all real numbers. And therefore it is certainly continuous on the interval from 1 to 8. So let's go ahead and tackle the task of finding the antiderivative for this function. In preparation for finding that antiderivative, let's rewrite our integrand as x to the 1/3 power, rewriting this cube root function as x to the 1/3 power and adding 1 dx. Now, to find our antiderivative, we need to recognize that, in essence, this x to the 1/3 power was derived from using the power rule. And so its antiderivative will require adding 1 to that exponent. So we'll have x to the 1/3 plus 1 power, and then I do need to multiply by 1 over that power. So that gives us the antiderivative of our first term, plus, and then the antiderivative of 1 is x. And we're going to evaluate that between x equals 1 and x equals 8. So at this point, we have x to the 4/3 power plus x, and this coefficient that we have to the x to the 4/3 power is 1 over 4/3, and 1 divided by 4/3 is in essence the same as as 1 times 3/4, which gives us, in this case, a coefficient of 3/4. And again, we're evaluating this from 1 to 8. Now we can check to make sure we've done this correctly by taking the derivative of 3/4 x to the 4/3 plus x, and that derivative is 3/4 times 4/3 x to the 4/3 minus 1 power plus the derivative of x being 1. And 4/3 times 3/4 is 1. So we end up with x to the 1/3 power plus 1, which matches our integrand. So we have confidence that our antiderivative is correct. So continuing on, now we need to substitute in our limits of integration and continue to evaluate. So we're going to have 3/4 times 8 to the 4/3 power plus 8 minus 3/4 times 1 to the 4/3 power plus 1. So continuing on, I have 3/4. Now I know that 8 is a perfect cube, so I'm going to rewrite 8 as 2 cubed to the 4/3 power plus 8 minus, and then we have 3/4. Well, 3/4 times 1 to the 4/3 power. 1 to the 4/3 power is simply 1, and 1 times 3/4 is simply 3/4. So we'll just have 3/4 as the first term here in our second group, and then plus 1. Now I notice that I have 2 cubed to the 4/3 power. And when I have a base to a power embedded within another power, we multiply exponents. And so when I multiply this exponent of 3 times this exponent of 4/3, I get a new exponent that is their product. And in this case, that is 4. So we have 3/4 times 2 to the 4th power plus 8 minus, and then 3/4 plus 1/4, that's 7/4. Continuing on to simplify, this 4 can divide out 2 of the factors of 2. So 2 to the 4th, this 4 is actually 2 squared, so this can simplify, and we end up with a 2 squared remaining. So 3 times 2 squared, 3 times 4 is 12, and 12 plus 8 is 20. So right now we have 20 minus 7/4. And if we get a common denominator of 4, my 20 becomes 80, and then minus 7 all over 4. And then 80 minus 7 over 4 will give us 73/4. And that's the value of this definite integral. I hope you find this helpful.